We're rolling audio. You rolling video?
Video.
Okay.
Woo. That was great. The crowd goes wild. Thank you. Thank you very much.
There we go.
Thank you.
Welcome back to our video podcast once again. I'm Josh, and I have some guests with me, and this is not the same day as the one we did before. Obviously we have all changed and gone home
my shirt.
and showered, and it's been many hours between the last time we were here together.
Oh my goodness, it's good to see you.
It's good to see you. It's been a while.
It has been a while. How you doing?
I'm doing all right.
I like the beard.
Thank you. Thank you. It's I didn't have it last time we talked.
No,
I don't think.
That's right.
I think it's new.
Yeah.
So we joke around recording this our video podcast, and it's because we don't have a great name for it yet.
Right.
So maybe these guys are pretty smart guys. Again, with me is John Carrico and Mike Loucks of Space Exploration Engineering. Also with us is AGI Systems Engineer Austin Claybrook over there. We're going to be talking about Apollo 11 and Apollo 13 a little bit. But first, I think maybe we should brainstorm a little bit about what could we change the name of this podcast to. So the podcast is about aerospace and defense and satellites, and mostly space and satellite type things and debris, and we'll get into asteroids and things. So what do you got, John? What do you got for us?
Spacecast. Why not just the Spacecast?
It's not bad. Not bad.
Spacecast, coast to coast.
Right, exactly. Or libration points. Yeah, that's good.
Welcome to the libration points.
That's right.
You're gonna come back every time we do it.
Yeah.
Just for that introduction.
That's
I
right.
think. Yeah,
That's
that would
right.
be perfect.
Yeah.
Austin, you got anything?
I don't know. I like the Spacecast.
Spacecast is not bad. Not bad.
I think lunatics, being somewhat moon biased.
That would be a good one and accurate.
Lunatics, I like that one.
We were joking earlier, maybe lowbrow, high eccentricity.
I've got an inclination for that.
Thank you.
Yeah.
That's great.
Yeah.
All right. Well, if anybody else has any good ideas, just leave us notes in the comments to what we think we should call this.
How about true anomalies?
True.
Thank you.
It's pretty good. All right. So today we wanted to talk a little bit about Apollo 11. It is the 50th anniversary of landing on the moon for the first time, and we have some people here that actually have recreated this. Austin did it for. He's doing a webinar next week and a training the week after that, or 2 weeks for the webinar and a training the week after that. And he went through the old documents and recreated everything to be accurate, down to every burn that you could find information about. And previously, before that, John and Mike, I think Mike was more on this, is when Apollo 13 was on the 40th anniversary, we did some analysis, or you guys did some analysis.
Might have been the 30th.
It's the 40th.
Yeah, I
I'm
think
pretty
it's
sure.
the 40th, yeah.
The reason I know is because it still gets a ton of views on YouTube, and it says 40th in the titles. Either I wrote the
Can't be
title
wrong.
or
Well, so we're about to get the 50th of Apollo 11, right? So Apollo 13 would have come a couple years after that.
Mm-hmm.
But I think it was.
How many years ago was
It
it?
was 2000.
I'll tell you in a second.
I think it was 2000 when we did
It's
it.
not the 13th anniversary?
Yeah, I don't think so.
Because I met Chuck Dietrich, one of the Apollo retro officers, a mission control guy, because of working on the Apollo 13 reconstruction that we did. And Chuck came to my house in 2002.
Oh, okay.
So I met him, but it had to be the 30th.
The 30th.
The 40th would have been in 2010.
So I think the video is probably from
Well, there might
2010.
be
Well,
a
the
more
analysis
recent video.
was
Yeah,
2000.
Yeah, I think the analysis was 2000, yeah.
Okay.
And so, can you talk about that a little bit? What you were saying, recreation. What were you doing?
Well, so it was, like we said, the 30th anniversary of the Apollo 13 mission, and so we were trying to recreate the trajectory. And so I was working here at AGI with Bob Hall and John here, and we were trying to recreate that mission. And so we knew when it launched, and we had some information about the trajectory, but we didn't know. We knew there was stuff in the books, and it's not altogether. It's not like they give you a really precise state vector, and they don't have the ephemeris modeled or any of that. So you have to kind of do detective work and recreate it. And so I had a trajectory that roughly matched it, but Bob managed to get a hold, I think through Andy Chaikin, of a friend of ours now named Chuck Dietrich. And Chuck was a mission control guy, the retrofire officer on the Apollo missions. And so we called Chuck and said, hey, what data do you have? And he says, well, I'm going to go down in my basement here. I've got a state vector. And so he goes down to his basement in a box, and he's got a piece of paper that's got a state vector from right before they had the explosion on Apollo 13. It was the last update that they did, and he had it in. It was a coordinate system that was funky. It was like
our state vectors today are usually like position and velocity,
right.
And we have that in X, Y, and Z with respect to the star's coordinates. And
so I'm remembering more of what happened here because I had recreated the trajectory based on the information that I had, and then and so my information looked good. I flew around the moon and I came back and I was hitting the Earth in the right spot for the recovery. And then what Bob had asked me to do was to look at what happened if the mission had not performed any of the maneuvers after the explosion had taken place.
There was a
because there was in the movie they go into that in detail.
Well,
and
the DC plus 4 hour burn.
Well, there was several burns, but what the question was, what if they had done none of the burns? Would they have gotten back? Where would the spacecraft have gone? And someone had made a statement in one of the some of the documentation about this that they'd have been in this orbit forever in the Earth Moon system.
Well, I think just to back up a second, what it was is they went on a free return. So it was going to come back to the Earth. Then they did a burn to get off the free return when the anomaly happened.
Well, right after that, yeah. So they got off the free return, and then the anomaly happened. And then once they figured out they were on the explosion had taken place, they needed to put themselves back onto a free return.
Right.
So if they hadn't put themselves back onto a free return, what would have happened was the question. So Bob asked me that because it had been stated in several books what would have happened there. And I think actually Andy Chaikin's book had a comment about this. And it had come from some analysis that had been done somewhere, and we didn't know where at the time. And so I duplicated the trajectory, and everything else looked right. But then when I tried to do that part and I took the maneuvers out, we didn't come back to the Earth, but we did like a month later, and we crashed into it. And so Bob's like, well, is that right? I think it is.
The book,
based on what I'd seen.
But the book said they would go into heliocentric space and orbit the sun forever.
Right, and then it's part of the movie. Your favorite movie is they say
they just said they would stay there as a permanent monument to the space program. I don't know that it was specific about where it would go, but it just was that they would stay. And so I don't know if that meant heliocentric or centered. It wasn't some specific thing. But when we looked at it, we weren't getting that. And so then that's when we contacted Chuck, and he goes, oh, well, I've got a state vector. So then he gave us his state vector, which was in this unusual coordinate frame that we hadn't heard of. It was like north, down, and
forward or something.
Yeah, something that we didn't, wasn't one of our standard.
Left-hand rule.
Wasn't X, Y, and Z.
Yeah. Wasn't what we were normal. So we kind of figured that out. But we put in his state vector, we found it actually matched really well to what I already had. And so then we figured out from there that actually the whole would have the idea of how far it would have missed the moon wasn't quite right, and that had just in Chuck's documentation when he pulled it out, he actually had the right altitude in there for the flyby, and he couldn't figure out how that got into the documentation, but he remembered that it was there. So we had fun with that. We got to meet Chuck. Chuck's now a friend of mine and a great guy, and there was lots of neat things that we found out just by duplicating that trajectory. And
we did a paper with him.
Right.
Yeah.
We did a paper with him later on lunar trajectories, but anyway, it was fun to do that, and it was fun to look at the real data, and also it was cool to have figured out the trajectory and then went and got some data and found that you were actually hitting it. So, and then we discovered something different about it too, that the historical thing that was different than what had been published. So.
Yeah. And the paper we did with Chuck,
right, we
created some software that I think Austin was actually using.
I'm pretty familiar with it by now.
Right.
Yeah.
Right.
So Austin, you've gone through the pains of meticulously recreating the Apollo 11 thing. The whole mission and all the pieces of it. And so where did you get your data for that one?
So as Mike said, it's been a whole bunch of detective work. So back actually before this project, back when I was an undergrad, I did a little bit of work on the Apollo missions, their extravehicular activities, the EVAs, so their spacewalks. So I already had a little bit of familiarity with the details. And back then I got all my information from the original mission reports. So right before the missions flew, a couple months in advance, they'd post the flight plan, and then afterwards they'd post the actual mission report as it actually flew. So I have spent many hours, probably too many hours of my adult life, looking through these documents. And these are all typewritten back in the 1970s. So you get fun little typos that you can discover. There's some pretty interesting typos that I found during my recreation of this Apollo mission. Stuff that's I've seen published in various sources, but once you go and actually build the trajectory, the numbers don't line up. So there's been a lot of...
So there's typos not just in words, but in numbers and things, like values.
They're not a bunch of them, but there are in a couple places there's some pretty important events that it's like, well, I don't understand how it could go from 60 kilometers down to 5 and then back up to 60 in, like 20 minutes. Something looks a little fishy there. But yeah, most of my data was coming from original sources, those 1970 mission reports from the Apollo 11 mission. And then as needed, there's another book called Apollo by the Numbers. I don't remember the author of that off the top of my head, but I've got a lot of information from there and just verifying, cross-referencing. And then Google's my friend too.
Great. So what was the hardest part of the recreation? Just finding the data?
So finding the data was definitely one of the top 2 or 3 challenges, maybe the most important. The other one was really, I guess, like detection or kind of anomaly work where the numbers don't line up. You have conflicting data saying this can't be true and this at the same time. So matching, like, where is my spacecraft when I have different sources of information saying I'm in different places.
Mm-hmm.
They're all relatively close, but getting the numbers to actually line up really well with modern day software, doing all the actual physics, are really close to it. Getting some of those discontinuous sources to match up, that was probably some of the hard part. That and the moon landing itself. So it's really impressive that they did that way back in '69.
Yeah, for sure. Yeah. And that sounds very similar to the same sort of problems that you were running into when you were doing this stuff. Is it's 50 years on and still not an easy problem to solve. Even with the technology that we have today.
Right, and you don't get, like we can today, a full ephemeris. There's not like an electronic file laying around, and they didn't even calculate all of that stuff. So, they knew where the spacecraft was at certain points in time, but that data isn't, those state vectors aren't in the publications, and so you're having to, like I said, just kind of guess at it, or they might tell you, for example, well, we hit this spot on the Earth at this time. Okay, well, no, I can go do that, and so you can duplicate those things, and so you can pretty much guess that the things you did before that got you there are probably right, but you're not sure because you didn't fly it. And, in my case, I was lucky enough that there was a guy that I got to talk to that knew the stuff. So once I got him on the phone, then I could say, hey, Chuck, is this right or did we do this? And then, you could figure it out. But otherwise, if you're looking at 2 different sources of information that have different data in them, you're like, oh, now what, So
Now, some of it, though, you can figure out where they should have done something.
Right, yeah.
Just from normal physics.
That's right.
So.
Yeah, so I looked it up, the video they were talking about earlier. The April 2010 marks the 40th anniversary of Apollo 13, and that was the video where Andrew Chaikin actually tells the story and narrates that up on the YouTube channel that we have. So
nice.
the analysis was done before that, but the
so
40th
we did the analysis on the 30th anniversary, and Chaikin actually did a radio cast of talking about that same thing. And I think what happened on the 40th anniversary was we had him duplicate that because he had done it before. And there was an article I remember on I think space.com at the time too that talked about that whole finding. Yeah, that was fun.
So what advice do either of you have, or you two, John, the figuring out how to get to the moon and planning your lunar trajectories, or recreation for that matter? Like
Don't make mistakes with the numbers.
Don't make mistakes with the numbers. Got it.
Yeah.
I missed that one.
Yeah.
So
Don't use a typewriter.
That's right.
accurately capture the data that you need for later.
Yeah, I mean, when you're recreating it, you're not flying a mission, so it's really important to just have fun with it. Because if you're passionate about it and you can look into the stuff and you can really read what's going on and figure it out, that's really satisfying to figure it out for yourself and then duplicate it and see what it actually did. So that's really fun. That's a fun. I mean, when you're flying the mission, it's fun too, but it's a different kind of fun with a little bit different stress involved with it.
Awesome. Yeah. So there's a link on the website for Austin's webinar coming up and his trainings coming up. So if you want to learn how to recreate the Apollo 11 mission and use Astrogator, sign up for that. And thanks for your time, guys.
You bet.
That's it. See you guys next time.
Thanks, man.
See ya.